Let's get everything ready. I don't think anybody's here yet. So I glanced at this yesterday. So last night, really. Haven't read thoroughly. I'm not even sure we can do this. So, but we will try, just like always. But I know what we're going to be doing. We're going to be doing the discovery that Vinky had us realize about being able to pass in input inside a range function, which I never thought of, nor did I ever try. So, all right, let's get this over here, the URL. No, that'll blur in. There we go. All right, you're given a zero-indexed array of integers, nums of n. You are initially positioned at num0, so first element. Each element, nums I, represents the max length. Wait a minute. Each element, nums I, represents the max length of a forward jumping index I. Max length is how far. Okay, all right. In other words, if you are at nums I, you can jump to any nums I plus j, where j is in between 0 and nums I, and I plus j is less than n. All right. Return the minimum number of jumps to reach nums n minus 1. The test case are generated such that each nums n minus 1 example. All right. I do better with the examples. Oh, I didn't get on Discord. Hang on. First unmute. And then... Oh, and Vicky had a great idea for doing a quiz on the Discord server, a weekly quiz. I'm like, that's actually a really good idea. All right, so we're given the input 2, 3, 1, 1, 4. All right, the output is 2. The minimum jump, the number of jumps to reach the last index is 2. Jump 1 step from 0 to 1, then 3 steps to the last one. All right, that didn't help me at all. Okay. Oh, and the tutoring was interesting yesterday. We covered a lot of concepts, but the online platform that the university is using is very, very particular. There were quite a few tests that were failing that should have not been failing. I was bewildered by them. All right. For each element, nums I represents the max length of a forward jump from index I. All right, so my interpretation of this, which is integers m, the length of n. So the length of n, I is the position, correct? The first position. let's do 1. So starting point, you can go by 2. And then it's going to jump here and here. So that's 2. So let's see. All right. My interpretation of this is we are going to be beginning at the 0 index, which is I. Then that is also how many indices can it jump forward, and how long will it take to complete the end of the list. That's my interpretation of this, because again, we have here's okay, the minimum number of jumps to reach the last index is 2. Jump 1 steps from 0 index 0 to 1, then 3 steps to the next index. Wait a minute, okay. 1 jump step from index, then 3 steps to the last. Oh. Well, this is absurd. These are the exact same 2 numbers in the same output. So my interpretation of this is, so jump 1, you get to here, then the value of that jump is 3, and then you're able to jump 3 indices. That doesn't make sense. All right, let's go back to here. In other words, if they are at nums I, you can jump to any nums I plus j, where j is in between. So they're already interchanging. They're interchanging a value as an indices and a value between of what's being pulled, and then I plus j has to be less than n, which n is the length of the integer. Okay, so let's bring these down here, and let's just see if we can start to play with these. Hello, Cuckoo. Glad to have you here again today. So I'm not... Hang on. My wife has an interview. Hang on, yeah, it is today. Oh, thank you, everyone. I think Cuckoo, I don't know who hit the like button. Give me 1 second. There we are. All right, so kind of back to Cuckoo hit the like button. So if everyone else who's here, if you could hit it. Thank you, Cuckoo. So all right, so this, I'm kind of all over the place. All right, let's move this in here. Paste nums. I'm about to quit where I work and dedicate myself to learn Python. Well, that's cool. That's a bold move, but I think that's awesome. So all right, so len of nums is 5. So but here's what's throwing me off. Not only so zero index array, I don't know why that seems redundant. Each element I represents the max length of a forward jump. All right, there we go. So when you move over, but wait a minute, I'm here at 0 index, so the max jump is 2. Or is it we need to find in this next group what the max number is? All right, let's reread this. For each element, nums I represents the max length of forward jump from index I. All right, in other words, if you are at nums I, you can jump to any nums I plus j. And there we go. All right. So let's go over. Okay, I think I'm getting this. So J is the number between, and we want to find the max. All right. So max, or the minimum number, was it the minimum number of jumps? I see why this is a medium. All right. So we have to split the list in half ish. Well, my interpretation is we're going to be slicing out indices. So first let's design this. And I have a hard break today because I got to go take a car to get tires. So I have to break at a certain time, probably a little over an hour from now. Let's check the lighting, see how we are. We may be, yeah, we're going to call this something here. Hang on a second. How bad? That's not bad. All right. The lighting was up a little bit more. All right. Glasses. No, keep my glasses down. All right. Coolest thing I've learned. All right. So far. All right. Coolest thing I've learned so far. Hi, everybody. This is Sam with Python Basics. So this is another absolutely awesome thing that I've learned while we've been messing around with our live streams. So we were working on something the other day, and we were taking in input, and then we were going to do a range. But check this out. So in print I, right? So I do F9, I print 5, I go 0, 1, 2, 3, 4. Now, I had no idea this was even possible. One of our subscribers and viewers goes, hey, can't we just put it in? I've never seen this anywhere else. Let's comment this out so it doesn't look like I accidentally grab it. But watch this. You can literally nest an input inside of a range function. Now, it does not work if you need to recall that variable at a later time. But if you just need an input and to be able to grab something from the user, you can actually nest it inside the range function. I've never seen anybody else do this. I doubt we're the only ones that have figured this out, but I have a very strong feeling this is the only... I have a very strong feeling that this is the only video on YouTube for Python for something like this. There may be some little crooks somewhere on the internet, a Reddit post, something like that, a stacks somewhere. But I just thought this was very interesting, and these are the things that we stumble across, either discover or rediscover. So just want to make sure that everyone is aware of the live streams that we're doing pretty much every day, because we've gotten into a pretty good routine of doing these, and the community is growing, and what I truly enjoy the most is the amount of support that we're giving everyone. So if you're not on the Discord server down below, make sure you're joining that, and you're getting the help that you need and deserve. But as always, everyone, thank you so much for watching. Please drop any comments, questions, video requests. Hit that like button, subscribe button, notification bell. And as always, thank you, everyone, for watching, and we'll see you next time. Bye. All right, there we go. Got that done. That was like 2-something minutes. All right. Oh, yes. Are we referring to me going and taking tires? Yes, very expensive. JavaScript? No, I don't know if I've ever written any JavaScript, and I may need to, when the sun starts coming in, I may need to hang up some towels, so we may need to do that. Vinky, how are you? No, I do not know JavaScript. That doesn't intrigue me. So I tend to only do content that I enjoy doing. So it comes across with purpose and motivation. So I wish I could help you, but it does not intrigue me at all. So more web stuff. Oh, Vinky, I don't know if you saw, but I just did the video of your thoughts about this. So and I was like, I don't think there's a video out there. So we just did this. So I just recorded that. So now I don't know if you've checked the link, but I may need some assistance on interpretation, but I think we have this so far. So we're given a list length in. All right, so that is important because this jump, we're going to be able to, so we start here at index 0, and for each element, I represents the max length. So the max length, so right now we can, and it's I plus j less than, that's the constraint. So this is, all right. So right now, let's get I in here. I is 0. Num's value of I is num's I is 2. All right. So here's, wait a minute, value of I is j. All right. Yeah. That's what I'm messing up. All right, so j now, and the length of is len nums length is 5. So, all right, so there's a lot of calculations here and a lot of rules. Dax, good morning. Python or JavaScript, which one is best? It all depends on what you want to accomplish. I mean, they are different. Exactly what Cuckoo says. I mean, it's like, a saw and a hammer, which one's better? I mean, if you have to cut something, the saw's better. If you need to hammer something, the hammer's better. But I mean, which is better for what? So that's what you want to ask. And anyway, I was having this discussion when I was tutoring yesterday. Don't get hung up on the language. And this is what has been reaffirmed for me over the past probably 2 months since we've been doing this, is the language is arbitrary, doesn't matter. It's the programming. It's how are you setting up order of operations? How are you utilizing memory? How many times are you iterating through the sequence? Are you being efficient? Is your algorithm, is it handling all edge cases? Those are the type of questions that you really need to be asking. All right. That's a pretty good, Dax. That's a pretty good. And yeah, so the reason why I've kind of fell back into data, just because when you're moving things around, you're having to problem solve, and you do when you're building. If it is like find the minimum number of jumps required to each last index, starting with the first. It's going to be something similar to that, Vinky, with this little constraint here, which I'm trying to make sure that I'm understanding what this constraint is. So when we first hit I index, it's 0. Then what happens is then the value of j, so it has to be between 0 and the value. So it has to be 0 to 2. So 0 would be staying stationary. 1 jump would be here. 2 jump would be here. And I'm assuming what they're doing is then they're choosing 3, but then here's also the constraint. The index 0 plus the jump has to be less than the length. So there is a lot. There's a lot going on here, but I think we're really close. And I wanted to stick with the medium series because I think we got some more viewers. And I don't know what has exactly happened. If you guys are noticing back with the monetization and the ads, I had to turn it back on because the day that I turned it off, my recommendations were dropping drastically. They're called impressions. So it was right around this exact same time that it was the same day. So I have to play so I apologize for all the ads. I have to play the game with YouTube. So thank you everybody for hanging in there. All right. So Vinky's got length -1. Yeah, it's going to be, always indexing. Yeah. Always that, okay. As it stores, you get a discount. Let's say 50%. It means up to 50%. And it can be 10, 30, 50. Yes. Similarly, just 2 jumps means 1. Yes, you're exact. I believe you're exact. Or range, since range does not go to the last element. Range does go to the last element. I'm not I think I know what you're talking about. That we need to make sure that we don't jump past the last element. And I think we also then need to land on the last element. I think that's going to also need to be. So length equals len nums. So we need to have that. All right. So what I'm really, there it is. Okay. I wanted to see this again. So it is, I thought I read it, wanted to make sure. Our initial starting point is we're starting at index 0. Start. Now we'll do I. I set it to 0. All right. 0. All right. So we're starting at I. Starting at 0 index. So if you're super new, I like to do this. 0, 1, 2, 3, 4. All right. So we need to land also, because let's reread. Number of jumps to reach nums n minus 1. So, all right, let's talk about this for a second. The test cases are generated such that you can reach nums minus 1. This is the last index. So, okay, you can jump up to 2 steps to indices. Yes, because indices 0 has a value of 2. So I can jump up to 2. And then as long as the index, so right here, index is I. Do I have I as 0? Okay. Then my j is the value of 2. Actually, let's change this to n so we stay consistent. And everybody check my logic on this, because that's actually where I have more trouble, is with human brain. My n, that's part of my challenges. My Python is great, and my processing is great, but the n is fried. And my out, it's great, it's awesome, it's the best. But I've learned to work around this. So if you're super new, I see this and I get this completely of what this is saying. So n is 5, but if I do nums n, I'm out of range because 0 indexing. So that's why we have to do nums n minus 1, because this is the 4th index. So my n was 5. This is not index 5. Index 5 is over here out of range. So this is why the formula for reaching the last element is n minus 1. Just to cover everything. So now our next constraint. So our jump can be net, but okay. So we're not picking 2 because then our largest jump is just 1. So it would take us, if we would jump over to, if we were to jump 2, we would then land on 1. And then our biggest jump 1 would be another 1. And then our biggest jump 1 would be, so by doing our biggest jump first, it's actually going to take longer. So we need to be able to then slice out and find the max. Oh boy, this time complexity is going to be awful for my first attempt. But Venki, you start working on this as well. Venki is our resident math genius. All right, so if I'm understanding this right, so our constraint, we have 2 constraints. Find the max and the sliced just is jump is half the length of the list. No. Okay, sorry. That's on me. All right, let me make sure I read this whole thing from Cuckoo. Jump is half the length of the list and create a step that will be a third of the length. All right. I don't interpret it that way. Let me go back here. So we start at index 0. So our j is 2. So we can actually adjust j. We don't have to pick 2. I want to actually show you this. We actually want to slice this list out. So let me make sure, because augment by 1 or 2. So let me work on the formula for this. So I is 0. And then nums I plus 1 through I plus j. That's not what I wanted, because I want I plus j plus 1. There we go. All right, so here's our formula. So then we're going to pick okay. So then we're going to iterate through this to then find, my time complexity on my first guess is going to be absolutely awful. But I'm getting it out of my head, and then we're going to see if there's a better way to do this. So does everybody understand what I did here? I don't know if this is 100% correct, but this is what we did, because we looked at 3 and 1. And we picked 3 because it gets us to the end of the list. It's a start. Yeah, that's a good way to put it. Good. It's a start. So because we don't want 1, because that's just going to be bad. So, and wait a minute. We necessarily, so all right, okay, it's not, okay, I'm a little bit off here. It's the max of this. It's not the list itself. So if, let's say this list was shortened a little bit. Let's copy both these. And I want to see if I understand this. I just realized something. So, all right. It doesn't have to be one of these two. It just has to be a value between this and this. So we would still do 2 jumps to get to the end, because our jump could be 2. Because this is my interpretation, it is in between, j can be in between the values and the 2 or 3. Yes, since you can jump 1 or 2 indices, and from 2 to 4 jumps, 3 jumps is one jump at a time, since we have the value of index 1 is 3. That's my interpretation of it. Yes. All right, hang on. Let me put up the towels. I see a whole bunch of backlight. Bear with me, everyone. Like I said, I had people. We had some people over, and my wife was like, "You're gonna take down the towels that are on the window, aren't you?" And I'm like, "Yes." So now I got to figure out how to put them back up. All right, let's do that. Let me do one more. She's like, but I thought you had drapes. I'm like, yeah, that's for the other window. She's like, oh my God. I'm like, I know. But us guys don't always have elegant solutions. Okay. Let's see. And the only problem is it kills a lot of the front light. And there we go. Let's turn that back on. Okay, let's go. Let's get going back. Thank you, everyone, for being patient. Depends on the specific value within the array. Okay, that will depend on the length of the array or list. Yes, so it can sit between, but it has to be but then the second, it says and, let's put these on the same line. Let's get this down here so my eyes will jump at it. So it can be up to, but also then I and j. So j is the value, but then also turns into the index. So where do we get the j from? Because that's a bit, oh, it's very strange. It's extremely strange. So we have control over j. So since our first, I guess, actually, in that example, either one of these would, no, that'd be 2 jumps. So since j has a max value, so think about it like that. So j could be up to 3 as long as I and j are less than n. So let's look at this. So n is now 4, and so I is 0, and then n is 4. So the value of I is 2. So my j could be in between 2, 1, or 0, what my jump is. And as long as my jump, my j is the number of steps you can take forward. Yes, that's what my interpretation is j is how many steps. So since we landed here and we moved over, see, we didn't move over 2 steps, we moved over 1 step. But you can look, it can either be 3, 2, 1, or 0, because it is here. That's my interpretation of this. So we're going to find out here in a minute. But the only problem is how many times I'm going to iterate through this. That's what scares me. All right. Somebody just sent something in chat I don't recognize. So we have n is a max. Bingo. N is the max. No. N is the length. N is the length of the list. Let me see where it's documented. Length of n. So we do have a constraint on the length. So you can't jump. You can't jump more. So this is where you are to get value j. So if I was, I can already see this as a constraint. So let's see. N is the max value of the list. N is the max value. N is the length of the list. Okay, then we need to go through that list and start at index 0, and the max number of jumps has to be 2. Here, I'll go back a step, and you tell me if this helps. So we started at index 0, value of 2, up to 2. So we could jump either 2, 1, or 0. Well, to be this most efficient, I'm going to jump 1. Because if I jumped the max 2, I would get a value of 1. And then my largest jump after that would be another 1. And then another 1. So it would take me 1, 2, 3, 4 jumps to get to the end. Where if I jump here 1, and then I jump another, I jump this max, which happens to get me to the end of the list. I do it in 2 jumps. So, or j as a smaller than the length of the list. Not just j smaller than the length of the list, j plus I. So the value that you're going to choose plus the index that you currently are has to be less than n. I can't see the use case right here, but I can see how this is going to become a problem very easily. We also need to find the max. Yes, and then we're going to need to decrement because of this situation, and this is also helping us, if you think about this, this is also helping us make sure that we're not jumping outside the length of the list, or hitting, because it'd be n-1 is the last object. Okay, good. Yes, this is not an easy one because it's not easy. It's medium. So I know that's a little cheesy. My bad. All right, so I have a timer set. So if you hear my device go off, I'm gonna start to wrap up, and we'll wrap up quickly, and then because I gotta do some things and then head out. All right. So I think we're going to utilize this as a big test. So so let's kind of go through our human brain of how we decided this. So I'm here. So my n and my j. So I'm starting here. So I need to get all right, so how did I decide I needed to get to here? How close am I? Because I then need to land on so what was the other length of the list? Let's look at this one. That was our made-up one. Let's do this. All right, 2, 3, 0, 4. Basically the same. Let's get another 4 in here. So what would we do? What would we do if this was 5? I guess it doesn't matter. Here we go. 1, 2, 3. All right, I think this is a good one. Here we are. So we want to jump, and the answer still is here too, from my interpretation of this. We land here, we jump over here, we jump over here. So let's put this in memory. So nums is this, I and j, and n is 6. All right, Vinky, this is kind of feeling like a math problem. Tell me if you feel this. So I need to get to 6, or I need to get to 5 minus. I need to get to 5. in the shortest number of math. I need to convert I need to get I to 5 in the shortest steps. Yep. I've been hanging out with Venki a lot. Venki, you still here? Because I think we got it. So, 5 minus 2, or 0 plus 2 plus 3 gets me 5. Zero plus 2 plus 3. All right, now we got to turn that into a formula. Does everybody see what I just did? So don't get hung up. Now we just have to do this math. Oh, I hope Venki's still here because I think he'd be very proud of what, because we've been hanging out a lot together, and this is exactly what Venki would do to solve this. Not just the max, but the max combinations to get us to n. N minus 1. To get us to n minus 1, where I plus j. Yeah. As long as it's this. All right. Oh, it was so interesting. You know how I was I harp on the number triangle. The young lady I had over here yesterday, they had to do it with stars. Oh, and it was very cool. It took me a minute. I had to rethink about it. It was a star problem like this. Put this down here, and it was this. And now I gotta fix this. So it was that and that. And it was these extra spaces that took me a minute. I was like, hey, give me a second to redo this. But yeah, it was interesting. Max I plus C. I don't think it's going to be. So let's look at this one. I don't think it's going to be max. I think it just has to be whatever gets us to. Because what happens if it was... Because it's the index, and then we need to iterate through. So it's almost like what... We're going to be searching for combinations to get us to the values of... Because we have to find... Because it does not... Because again... If I'm understanding this correctly, like we didn't jump 2 to get over here to 1. We only jumped 1 to get us. We jumped 1 because we decremented down. So we can go up to 2 places, but we chose not to because J can be anywhere in between those numbers. J is not. So J could be, let's do this. J could be anywhere between 0 and 2. 0, 1. How do I want to write this so everybody can see this? This doesn't make sense. 0, 1, or 2. J could be those. And the reason why we picked 1 is because it then... But is that what you're saying? Find the max number. Because that opens up our opportunities. But Venki, I guess hanging out with you as much as we have. This seems like we want to do this and just find the largest numbers. And how can I get to n minus 1? What combinations can I get to n minus 1 to accomplish this? That's my gut, but don't hold me to that because my gut can be very misleading too. So that's the trade-off. Sorry. Okay. Let's see. My brain is mush with this because I don't know if who all was here, but when I was helping tutoring yesterday, the online platform that the university was using is crazy picky. It was even judging new lines. Like there was this one problem. I've never been judged on a new line, and it wasn't making sense because everything that we were doing said everything that I know about new lines and new line suppression should have been working. So that's been in the back of my head and driving me nuts. And we also did one of these, and I had to rebuild it because it's got spaces in here. That's what threw me off. All right, so range of. Do we want to do it? We are going to look at it. Are we going to make a range? Or are we just going to, for range I, and then we loop? I feel how awful time complexity this is going to be. But wait a minute. But if we do the math here and we don't have to iterate through the list, we don't care. Because we need... Because what we need to do is we've got to get to the index here, but then we also have a limitation of where, because on this one, this list, the answer is still 2, because we would get to 2, we would jump 2, then we would jump 3. Because now watch this. Let's add... How many is this? 1, 2, 3, 4. All right, let's check this out. So we would jump 2, we would jump 2, then we would jump 4. So it'd be 1, 2, starting here. 1, 2, 3 jumps. That's my interpretation of this. And okay, so I is 0, n is 9. So I need 9 minus 1 minus 3 Let's make sure I can do this right. 2. Is that okay? That was it. 2, 2, and 4. 2 and 2. That was 4. All right. Because get me here. Get me here, get me here, get me there. Max value, not a max value, a max value. So we also then not only have to look for the max value, but then have to augment it. Does everybody agree with that? That's what we're doing? I wish they would have used a different, because I mean, look, this is basically the exact same. jump one step from index 0 to 1, then 3 steps to the last index. And then there's no explanation for the second one. Let me double check, but I don't believe there was. No, there was no explanation. And of course, this is the same. It's guaranteed that you will reach n minus 1. It's guaranteed that you will reach n minus 1. All right. You can't jump to index 1 since the value is 0. You can't jump anymore. That's a great point. So yes, you would need to. Yeah, that's what my interpretation of that is, and that's why we would jump over. Why we would jump. Well, yes. Okay, so we can build that in. Be like, we don't want to jump here. Vinky, do you kind of like the math angle that I was going with? But then we had to have to find the index combination. So not only are we trying to find the largest numbers so that then we can choose which numbers to pick. Like if we shortened this to here, it would still be the same because we would just jump 3. So it'd be 1 jump, 2 jump, 3 jump. Still be 3. Because as long as... Alright, does that change? Oh, hang on. Let's look at this. So let's go back over here. What is that? Just another 1? Oh, 0. That'd be cool. All right. Don't know if that's going to be right. All right. Okay. So we're here at. Let's put this in. Nums. So 0, 1, 2, 3, 4. Okay. Is this? I can't. Well, now I'm not sure if this would be a constraint because. Nums index 4 is 4. So this would be J. And I is 4. So let me just double check. Okay. Excuse me. Then I plus J less than N. Okay. So this may be redundant. This is going to be the one to have this be sliding around. I feel like we're close here. I just don't know how to implement it. I feel like we're very, 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 very close. All right. Because instead of us having to just iterate all the time, if we do this from a math point of view, like we did with the other one where we were summing, and we just do raw math, it's going to be faster because we're not actually going to be iterating through the list. But I maybe just be throwing up flares and be completely wrong. All right. I don't have my phone. I do have my phone. Sorry. And I don't know if I told you guys, I have a live stream, not Friday, but this whole weekend has been really weird. I have a live stream next week. And I have a advisory board call. I don't know if it's going to be any scam like, but I've been answering all my phone calls. Because who knows? Because sending out all these resumes, who knows who's legit or not. So I gotta take all the phone calls, which I never answer the phone. So it's funny now that I have to answer the phone all the time. Man, I'm stuck. All right, but we'll get through it. We'll figure it out. There's always a solution, one way or the other. All right, how's the volume today? I forgot to ask. And okay. Okay, so let's see. I want to take. Oh, I need to assign J. That was it. Nums equals I. Kratos, how are you? We're working on a really weird problem here. J is 2. So maybe I do need. What was that weird dynamic that I did? This thing. I'm just going to name this temp at first. Okay. Because you can't name it max because what are we doing today? Okay, Kratos. So it's a very interesting problem. It's get to the last index in the fewest steps. So there are a lot of constraints. So you are going to be utilizing the length of the list, which is n. You always start at index 0. Now, this is where it gets interesting. So you get. Actually, we don't need this. Sorry, admin. My admin Cardinal is direct messaging me. For those of you who don't know, Cardinal created the Discord server, so that's why we're able to have these communications. So, all right, Kratos. So, let you know this is a weird challenge. It's a really good problem. I guess we could just make this. No. Yeah. New J. Temp. New J. There we go. So this is an interesting feature. So we start at index 0. Now, you can jump up to the value of the max value of. Let me start over. You're supposed to get to the end of the list in the shortest number of jumps. Now, what the caveat is, so I and J has to be lower than, bingo. So I plus J has to be lower than the length of the list. Yes, N. 100% correct. Now, I don't think that's possible for it to be higher, but don't hold me to that. I feel like this is redundant because I feel like that would get you, overshoot you to outside of the range anyway. But that's just my go-to gut reaction. But so Kratos. So here we are in this list, and we'll go over these others. So you started at index 0 or this number 2 right here. And to get over here in 2 jumps, what you do is you choose to jump one time, an interval of 1, because it is in between this value j, the jump, the value of the distance j, is in between 0 and the value of the number at that index. So we default and we start. Well, that's not possible. To have I plus that's what I. Once you get to the last index, and then we add j as well as sep, it will be overshoot the end. So let's think of an edge case where that will happen. I don't think it will. Yeah, and Kratos, just bear with this explanation, and I think it'll get it. So I chose this if this is correct. So we're here. We start at index 0, a value of 2. So I'm going to jump the full value of 2 over here to 3. Now, I want to get to the end of the list as quickly as possible. Now, if I jump the full value of 3, I land here, and then I have to jump one more and then one more. Or if I'm here and I jump a value of 2, that gets me to the 4. Now, that gives me a lot more opportunity to get me where I just go 1, 2, 3, 4, and I get to the end of the list. So starting here, 2, 1 jump, 2 jump, 3 jump. So that is the dilemma. Now, I feel like this new j in this value here. So I'm here, and I could be jumping to either 0 or 3. So what I'm doing is I'm slicing here. Let's change this a little bit. I'll show you what I'm actually doing here, and then we'll comment this out. So I'm slicing this. So I'm looking for my next jump and my largest number, because I want to get to the end, but I also have stumbled across that possibly while I'm looking for this, our formula, our last index, 0, is always, so we did n is 9, and so nums n minus 1, I get 0. So if we really think about this, the shortest number of jumps, so n minus 1, hey baby, n minus 1, I get 8, right? So that's the index, and as you can see right here, index 0, or index 8. So I need to find numbers in here, or adjust j to get me to 8 minus, well, that's 4. 4 minus 2 gets me back here. So either way. So I got to here, I get to here, I get to here. I feel like this is because if I have 1, 2, 3, so I do math to accomplish my goal, because we're starting here, we're here, and I need to go through here. So we need to design math. Can I leap through here? Because if we're just constantly going through this list, our time complexity is going to be awful. And if you're super new here and you don't know what time complexity is how much time will it take for you to, how many times are you going through this list? The fastest way, of course, is where you don't actually go through the entire list at all. Like if you're looking for a non-prime number, once you find it, you stop. You don't have to check all the numbers. Or Venki's solution, where we were doing double pointers and we were coming in from both sides. We don't even go through the whole list. So you want to eliminate going through this list, because my first default is I'm going to slice this, and then I'm going to look for the largest number. Well, we're going to do this here. All right, Kratos. So, but they're correct. But Vinky, but is there a 5? Is there a value of 5 at all? So it has to be constrained by the max value of j. So, okay, let me read all this. So, for I in range n up to the farthest point we can reach from the current indexed farthest, max, farthest plus, I think that's, yeah, I think, but see that I'm slicing. So you're looking, not only, it's very constrained, and then I'll keep going down. So I need to find the max number here, so that's 3, but then I don't have to use 3. I can use anything below 3. So it's a very dynamic problem. Find the largest, and so here's an example. If we were to do this again, this would still be, and then I think, and then if we reach the end of the current jump range, we need to make another jump if I equal to current end jump plus 1 current end farthest. Kratos, I'm not sure I get that. If we can reach or surpass the last index. Well, if it's within, think about it like this. I can jump 10 feet, but the largest number that I see is only 8 feet away. I'm going to jump to 8 feet to make it so it's I can jump then 8 more feet. But if I jump my 10 feet and I land on 1, then my only next option is to jump 1. So I'm constantly looking for, in my jump, to find the largest number. So when I land, so I'm looking for the largest number, which then happens to be 3. So when I do this, new j, I'm slicing out this right here. So I want to find the largest number. Then, so that's when I added this max here. So then if I were to do this again, I want to then find the largest number, which is 4. And then I want to, each time I'm jumping, I'm constantly looking for the next largest number. And I'm subtracting where I am. I'm subtracting where I am from n. So that's the math. I'm looking. I'm jumping and I'm looking. I'm jumping, I'm looking. I'm jumping, I'm looking. Okay. And then as I'm and then now I need to augment this. So if we were to do this again, so I were to land here. So all right, I find new j, I get 3. All right. Is that mine or is that our device? Okay. No, I don't care. I don't think anybody else on here cares at all. We're having a good time. You're good. No, I don't know. Oh, I got another text. They're doing really good. It's in an hour. So are you still good to make it? No, you're not? Okay. Do any of you have daughters? Because they are a joy. 1 hour up. I have an alarm. I thought you were going to the hair appointment. Okay. She didn't want me there. She didn't want you there?
No.
Okay.
Well, actually, she didn't say that. I forgot.
Okay. What? Really? Okay, yeah. All right. Yeah, that's why I didn't say any names. You're good. All right, everyone here is cool. 1 hour up. Yeah, how long have we been on? Sorry. My daughter's off from school today. Some teacher what? Oh, sorry, Columbus Day. Columbus Day here in the US, in the States. 1 hour up. That's the index number. Hang on. That's the index number. Yes. So index number. So I know we are super close to this, and I was reminding our family friend yesterday, just because you don't get the right output, you don't get the right output, but your logic is right, because we're really close here, so we don't need this. This is redundant. Get rid of this. Whoa! I guess I did not. Seriously? Now my daughter's making fun of me. All right, new J. So, all right. So we need to. All right, I know we are super close because I'm here. Then before we move. Okay, it's going to be very similar to that one where we did the while. You remember how we went back and we looked again? And if, let me show you, is this it? It's going to be it's basically, we want to check again, and if it's not, then we move over. I'm trying to think of the one that we did where we did this exact same problem. There we go. Where we were moving this. So we were looking here. Then, I think this is it. Then if num and then the other one was, and then we did it. But if it wasn't, oh, is that where the syntax is? Huh. Okay. So we are so close to this. I can feel it. That's not it. Oh, that's Venky's awesome. That's Venky's double pointer right there. If you did not see that and you're missing out on these streams, I feel for you, because Venky is a math genius. All right. So I'm going to be possibly here. So I want to... So, all right. So this is a pure order of operations play on this, because we want to find out where we want to land to get us to here. All right. So I want to land. I feel like you always want to land on the largest number. All right. Because then J, okay. The first occurrence. All right, because I want to land on J. I want to land on 4. I want to land on 4. How can we get this for us to land on 4? All right. So then I were to change So new j all right, index. So how do we get to here? So this is index. Ooh, we do need this. We need to know its index, and we also need to know what the index is. Because we're going to need to do math to move it over. All right, let me try to explain that a little bit better. Because we're going to need to increment this over. So I underscore diff equals 0 right now. So while, and this is going to go in a while loop, while I less than n. We're going to comment this out right now. Oh my goodness. Like I said, I must stare at the keyboard so much more than I thought, because now I have this microphone in a blind spot and can't type. So this is because I need these so follow me through this. We need the indices because I need to know what position J is in. So max int new minus J is 3. Then so I want to find, so if I use, okay, if you don't know, is new, let's just do list. I can't remember. All right. So we're going to look at index and what this is. So help.list.index. Now what's coming to mind is what happens if there's more than one 3. Okay. Start value. Okay, we can control this. I forgot. So let's see. So I'm going to look at this list because I need to know what position 3 is in this. So we're at value I. Then we're starting at index 0. New J is this. So where's I? All right. So we got to figure out the formula for this. So watch this. Was it index? It's index. So new J dot index. Pass in the value. Watch this. Max new J, comma, and we're starting at I plus 1. There we go. Plus I. There we go. So now, I know this looks really weird, but hang in there with me. So here's my slice. I'm starting at I. Then I'm moving it over by 1. So now I know that 3 is at index 2. So I now need to move over my I to index 2. All right, I think my timer's about to go off, but we will be going. I'll probably finish this sometime tonight. Look at this number right here. Oh my goodness. It's because we have to have a constraint. Now the only problem is I can already see them doing this, having 2 3s side by side. Just 2 max numbers side by side. I will show the solution. So when I solve this, because what I have found is that if I take too long on a solution, especially going over a day, the audience does not like the same puzzle happening 2 days in a row. How do I have so much patience? I'm old. So the trade-off of my issues that I have is I can sit here and work this so my obsessions and why I get stuck on things, that's bad for basically interacting with other people. But sitting here and becoming obsessed with solving this problem, I can just sit here and try this over. I'm old as well. Okay, all right. Cuckoo, I will try you. How old are you? And then I will answer mine. So, like my kids say, you were born in the 1900s. Yes, very much so. And then my younger son, which is, he thinks he's funny. He said, "Well, what was it like when everything was black and white?" Referring to, but I'm 47. So, Cuckoo, how old are you? So it's about 43. I got you beat. I had a feeling I did. There's only one person in our audience who has me by a few years. But I don't want to out them, as they've been around a long time and have been very cool to me. So yeah, I got you beat, Cuckoo, and that's fine. So just I just do this all the time. I've been a programmer at heart, and I didn't really realize I was. Kratos 19, that's awesome. But see, then you have the energy, and you have not gotten set in your ways of how to solve problems. So you have to wide range. I know, right? So no, my audience is literally. I've now cracked 22% women in the audience, which is very cool to me since I have a daughter. I think that's very awesome. All around the globe, it's pretty even now. I was very, very heavy in India. I would say at one point early on in the channel, it was around 30% of my views were coming from India. That was actually why I decided to join one of the Indian platforms, CodeDam, and just because the sheer numbers of audience members in India, and then the amount of individuals who are learning programming. So yeah, I actually have two groups that I've worked with, Cody Tech and CodeDam. And actually, I guess a third, Free Code Camp. I did some videos for them. I wrote an article, I think on there. I can't remember if it was, I think it was Free Code Camp. It may have been CodeDam. I can't remember. But all right. So I think we're coming up with our solution. And I really feel strongly about this. I really think we're in 10 years AGI and then API. Yeah, well, we still, but when I was growing up, we were all going to have flying cars and blah, 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 blah. But here's the way you have to think about it. There's still going to be people, and people are going to want to interact with people, and people are going to break stuff and things like that. So it's just going to assist us, and we're going to be out there thinking about things and solving problems. But I'm obsessed with this, and I think we need to look and see. I think we need to leverage this. We need to get from here to here, because we're not tied to a number. we're just tied to a range. Sure, Kratos. What do you want advice on? We have my timer's going to go off in probably like 2 minutes. So, Kratos, are you on the Discord server? So, because when we go off of stream here, we can still chat over there. Yeah, just okay. Universal basic income. We can focus on what we like. Well, I don't know. I'm hesitant about like I'm a beginner stage of programming. Just solve problems. It's just like if you want to go be good at hitting baseballs. Do you read about hitting baseballs, or you go and hit baseballs? You go and hit baseballs. If you want to become better at programming, you have to sit down and do these and just do problems over and over and over and over again. And you just have to either build something and the problems you're going to run across building them, or sit down and solve these coding challenges where you're just constantly learning and learning and learning and learning. Because what the trick is, one, you have to be able to design. How did we decide? How did we sit here and decide what numbers to do as we were moving through here? Well, we said, all right, so I need to get each step over here, wherever this is, wherever I am, then I need to decide what my next, that's actually the answer to this. Before I pick where I land here, what is, when I'm standing here in this group, what is the largest next? Oh, they almost stayed together. Here. Paint. I'm trying to beat my timer because I know it's about to go off. New. So here's the answer. It just dawned on me, and I know exactly how to do this. Venki, 1 to 2, 3 steps with 2 steps and 1 jump. 2 to 3 with 3 steps with 1 jump. I think if I read that, if I understand what you're saying, Venki, I think that's it. So here, let's do. So I jump. That's my first choice of jump. Here's my 1, 2, 3. Here's my second choice of jump. And then here's my third choice of jump. So when you're going to look at your possible jump here, where do I want to land to get me to my next biggest jump? So I jump here because my next one is here. And then how do I get to my biggest, if it's shorter than the list, if it's not this, what do I need to do? So now I kind of get it. So I'm here to here. What is out of my range here? What is my next? So I need to look. What is this distance? What is this distance? And I want to just always land on the largest number for my largest possibilities. So then that's how I decide that this is 2. And then this is 2. And this is 3. All right. There's my alarm. I couldn't remember quite when I set it off. But all right, everyone. If you've not joined the Discord server, do that. I'll work on this solution, and I will come up with an answer, and we'll post it tomorrow. And hope everyone has a good rest of their day. If it's evening time for you, hope you have a great night. But as always, thank you, everyone, for joining today. And I will see everyone tomorrow. Bye, everyone. Alexa, stop.